Okay, so this lesson is basically about negative exponents and the rules of using negative exponents. Okay, so when you're working with negative exponents, if you have x to the negative n, like we have here, x to the negative n, that equals 1 over x to the positive n. So you have to flip it, and you have to change the exponent, the negative exponent, to a positive exponent. Or if you have 1 over x to the negative exponent, then the x goes to the top, it moves up to the top, and it becomes x to the positive exponent. Here's an example. I have 2 to the negative 4. So since I have a negative exponent here, I'm going to go ahead and I'm going to make this 1 over 2 to the positive 4. And then that equals 1 over 2 times 2 times 2 times 2, which is 16. In this next example, I'm starting out with 1 on the top, 1 over 2 to the negative 4. So the 2 to the negative 4 is going to have to move up to the top because it's already in the bottom, so you can't put it down further on the bottom. It moves up to the top, and it becomes 2 to the positive 4 over 1, which is just 2 to the 4th, or 16. You can make it like this if you want, but it really just means 16 over 1, which is 16. Okay, here's some more examples. I have x to the negative 6, so I've got a negative exponent. So what do? It moves to the bottom, and it becomes 1 over x to the positive 6, and that's it. You're done, because you can't raise x to the 6. We don't know what x is. Okay, on the second example, I start out, I have 1 over y to the negative 2. Y to the negative 2 is in the denominator, so it has to move. When I have a negative exponent, it's got to move. Where does it move to? It's got to move up to the top. So when I move it up to the top, it's going to become, it's going to become y to the second, y to the positive 2. When you move it, the exponent becomes positive, over 1, which is just y to the second. And there's my answer. Okay, here's some examples where we have more than just negative exponents now. We're going to put all of it together. So I have this. I have 3, x to the 0, y to the negative 4. Here's what I want you to do. I want you to look at each number individually. And by each number, I mean 3 is a number, x to the 0 is a number, y to the negative 4 is a number. Let's look at the 3. Is there anything special about the 3? Nope, no 0 exponent, no exponent at all, just a 1 exponent if you don't see it, and no 0 exponent, so the 3 is just going to stay 3. Now I've got x to the 0. Anything to the 0 power becomes a 1. So that means times 1, because these all mean times, right? Okay, and then I've got y to the negative 4. Y to the negative 4. What happens when I see a negative exponent? I have to move it, right? It has to flip. So it's going to go to 1 over y to the positive 4. Now I need to multiply these three numbers together. 3 times 1 times 1 over y to the 4th. The way you do that, I have whole number, fraction. So I don't know if you remember this, but you take your whole numbers, change them to fractions, and we do, excuse me, we do numerator times numerator times numerator, which is 3, over denominator times denominator times denominator, which is y to the 4th. And we're done. Okay, let's look at the second one. Remember, we're going to look at each problem individually, or each number individually. We've got the 4, we've got x to the negative 2, and we've got y to the negative 6. So let's look at our 4. Anything special about it? Nope. So the 4 is going to stay exactly where it is. x to the negative 2. Anything special about this? Yeah, I've got a negative exponent. I'm not allowed to have negative exponents. So what do I do with a negative exponent? Oh yeah, I have to flip it. It's got to go down to the bottom, and it becomes x to the positive 2. And then y to the negative 6. Here we go. We've got y to the negative 6. It's in the bottom already. I can't put it further in the bottom, so I've got to move it. Where does it move to? It moves up to the top, and it becomes y to the positive 6 on top. And then and that's it. We're all done. Okay, and here's just a few more examples. So here I have 2 to the third, m to the fifth, y to the negative 2. Let's look at 2 to the third. 2 to the third power. There's no negative exponent, there's no zero exponent, it's just 2 to the third. What does 2 to the third equal? 2 times 2 times 2, which is 8. Okay, then I've got m to the fifth. M to the fifth. Anything special about that exponent? Nope. Can I raise m to the fifth? Nope, because I don't know what m is. So it's just m to the fifth. And then I have y to the negative 2. So in order to do, what do I do with a negative exponent? It has to flip, goes to the bottom and becomes y to the second in the bottom. Because remember, it has to move. So it becomes y to the second in the denominator. There we go. If you wanted to, you could have went 8 times m to the fifth times 1 over y squared. Put those each over 1 and then multiplied. 8 times m to the fifth times 1 is 8m to the fifth. 1 times y squared is y squared. Let's look at our second one. This is our last example for today. So I have m to the negative 1. What happens with the negative exponent? It's got to move. Moves down here. So I'm just going to take it and I'm going to write it m to the first down here. Then I have n to the 0 power. So n to the 0, anything to the 0 power is 1. So that just becomes a 1. Then I have 3. Look at the 3. Is there anything special about it? Nope. So I'm writing it right here on the bottom. 3. You could have written it behind the m, but we'll put it eventually in front of the m because that's proper algebra. And then I have r to the fourth. R to the fourth. Anything special about that r to the fourth? Nope. So it just stays r to the fourth. It stays right where it's at. So we have 1 over 3m r to the fourth. Because m to the first power just means m. There we go. There's our answer. And I have my joke for you in the next slide. So why couldn't the dog get the apple? He was barking up the wrong tree. Have a good one.